Hi everyone, and welcome for today's webinar about Alteryx Cloud AutoML. I'm gonna be going through all the steps needed to run this tool from Alteryx. So to begin with, my name is Hassan and I'm part of the training and enablement team at Data Meaning. I've been working in the data science field for more than 6 years. Mainly, I've used Python, R, and Alteryx. And I have applied data science in several industries as real estate, stock market, healthcare, and retail stores also. And I'm very glad today to introduce you to Alteryx AutoML, which I consider as an interactive development kit for preparing the machine learning pipeline you want to use or integrate with Alteryx Designer. But first, let me introduce you to talk about Data Meaning. So we are a boutique business intelligence consultancy founded in 2005, and we are based in Florida, DC, New Jersey, Chicago, India, Brazil, and along with our software partners, we provide end-to-end solutions in creative services, BI, data management, change management, and delivery management. We also can assist you with education and training, and that's it. So let's begin with the session for now. So our agenda for today, we're going to focus on the common steps we use for building a machine learning pipeline and why to use the Alteryx AutoML tool provided. And we're going to go over like a demonstration, simple demonstration to see this tool in action and how to integrate it with Alteryx Designer. And feel free to send any questions in the chat during the presentation. So basically, the common machine learning pipeline involves multiple steps. So those are in brief, like the basic steps in building the machine learning pipeline, which are the data preprocessing part, where data is being cleaned and formatted. And we can do multiple approaches for data cleansing and stuff like this. And then after doing this process, the insight extraction is applied by understanding the data we have and applying, like checking for correlation between different fields we have and applying feature engineering practices. After finishing from the data preparation part, which is presented by steps 1 and 2, the model implementation, and we need also to identify like what type of model is required to run on the data we have in order to get the futuristic values and analysis, like whether is it a classification problem we're trying to get, is it a regression, is it an unsupervised learning approach or stuff like this. And also in this stage in the model implementation, usually we do not like implement one single model for a certain use case. We implement multiple models. We apply some hyperparameter tuning. We do some model comparison in order to select the best model fit for us. And also like assessing the models we're comparing, we need a step for model evaluation through setting a certain evaluation criteria, such as like we're more interested into getting higher accuracy or through area under curve or the loss function and other criteria that can be used to serve this evaluation stuff. For the Alteryx AutoML service, and why, like in the main reasons we use or we recommend using this tool is simply having like an interactive machine learning pipeline that can be implementing in a user-friendly interface that like you can able to go through step-by-step procedure in moving around the main 4 points I've already mentioned for building this machine learning pipeline. And also like there is a rapid and agile like approach in implementing those pipelines with all options available on the interface from Alteryx AutoML that I'm going to show it to you in a bit in the demo part. And like all those steps are encapsulated within one place. So usually data manipulation is applied, whether you're using Alteryx or Python or any programming language. Data cleaning is applied, and within the same environment, you can do also the machine learning model. But for every model, you need to set its parameters aside in a like separated mode, whether it's through Alteryx or even if you went into like a granular level, getting your hands dirty with coding. Every model needs its own like tuning part or testing part that are more involved in the third and fourth steps in the machine learning pipeline by the evaluation or implementation of the model. Whereas using this tool, you will be able also to get those comparison applied within this one place. And also it enables you to generate a report after accomplishing everything related to the model implementation and evaluation, like an executive summary. Let me say as it's an executive summary of the comparison between the models and the best model selected, and how are the features correlated, and so on. I'm going to show you all of those steps in the demonstration part. And if you have any question, just let me know in the Q&A and the question parts. So basically, for the Alteryx AutoML, this is the main interface. This is the main interface we use for running those steps. On the left side here of the panel, you can see those steps like the preparation of data, the data insights, the feature engineering.
Hey, Hassan, quick stop there. Your screen share, it's on the PowerPoint slides.
Oh, sorry.
I think you need to share to the other screen.
Let me.
Okay, it's showing now.
Yeah, let me share everything from my screen. Okay, you can see my Chrome.
Yeah, it's on the web page now. Thank you.
Exactly. Thank you, man. Okay, so basically this is the main, this is the AutoML part. You can access it online from here. And on the left side, you can see the steps involved in building this machine learning pipeline, from data preparation, data insights, and so on. So for this demonstration, I'm using a data set. It's a social network ads data set, which includes age, data about customers, their age, their estimated salary, and their purchase behavior on a certain product. We have this data set over here. Whenever you import it from your local machine to this workflow, you can see like it's able to, the data, the column types are set through Alteryx. And also you have an indicator over here in this tab to assess the data health you have. So whenever you click on the data health tab, a job runs in the background, and it can gives you a rating for your data. So this data health is good. There's no null columns. The distribution for the columns, like if there is any kind of bias or something like this, you can have an intuition about it before proceeding with your machine learning pipelines, whether you have null columns or null rows, or even like outliers by columns. And this is like the first step in only acquiring the data to this pipeline. Whenever you click next, you will be able to select a target variable, the variable that we are trying to predict, which is the purchase behavior. And also we need to set the machine learning method, which is in our case like a classification machine learning approach. It's not a regression. Once we set those two parameters over here, I'm going to show you also the advanced tab from this one. So basically in this panel, you can see the data insights. You have three main tabs for getting like the correlations between the features we're having. So you can see there is, this is here, the mutual information matrix selected. There are multiple types of correlation. This is more like related to the information ontology, but you can select like the maximum numbers for the correlations. Okay, and there's also a code diagram that shows you how those variables are linked together. like this is the target variable. You can see as darker as whenever the connection is darker within two variables, it's showing a high correlation over here. And also from this one, you can, from this data insight tab, you can check if there are any outliers in the columns being used for the model. So usually it shows you like for those variables, like the age one, how it's distributed. This one, let me just minimize it. So this is the estimated salary column 2. We see there are no outliers in those two variables. And also the distribution for the estimated, you can see the distribution for the estimated salary over here, like how many instances in our data we have, how many rows we have that have an estimated salary of 80K. So there are like a bin, it's a binning approach. There's a bin of 81 rows that gets an estimated salary between 69 and 82.5K over here. So those like type of data preparation process or data insights, usually whether you're using Alteryx or any other tool, you need to do those manual steps and checking those correlations, checking for outliers, checking for distribution, whether there is any kind of bias in your data. And this is like one of the strength point of this tool over here, where everything is encapsulated in this one. And also you can see like the target variable you have, how many instances, how it's distributed. You can see over here like the data, it's a little bit more biased to the false variable for the target variable, the purchase. So there are more false values for the purchase. And also over here, you have like an advanced tab or option that evaluates the data. Like over here, we can set it to be we're evaluating our model based on the accuracy. You can set like the cross-validation false. Also over here, you can set how many, what is the percentage of the data to be held from the original data set in order to assess how the model is performing. So if we assign it over here for 30 or 20%, this means that we're gonna hide 20% of our data set and use it whenever we wanna evaluate our model. So we can feed it to the model that is selected and check how good is it performing in terms of accuracy. And this would be like a data that was never seen before by the model. So those settings can be set from the data insight tab before jumping to the next step over here for the feature engineering part. Let me just save it over here and go to the next step. Okay. So for the feature engineering, there's a terminology being used for primitives, which is like the typical primitives created or a transformation created in any data manipulation exercise, such as like getting the absolute value of numbers, adding a certain number, or adding numerically like this primitive name to get multiple columns concatenated. Those are typical, like is it a 0? This one results with a Boolean, a new column added, like as is 0 function, is it a null, is it less than a certain number, multipliers, even it can do like comparison, let's say greater than or equal, in case we have like, as our case, 2 columns, it will create a new columns that applies this function, like let's say for age and salary. So it creates a new column to determine like if a value in one list is greater or equal to the another list. And it automatically selects the numeric type columns and apply this transformation on multiple columns. So it's not a single column one. You can see over here, it's described in the transformation. And also like whenever you have a selected feature, you can see over here as like the created ones. Let me try a certain primitive like that is the one that shows on multiple columns. Okay, let me do the greater than. Again, let's save the change and go to the features part. We will be able to see it as an engineered feature, which was mutated by us while creating this new feature. You can see now the columns that the new columns created, the Boolean ones over here. So this column, it refers to whether the age is greater than the estimated salary. And here it also creates a new column for the opposite. And you can see like the engineered correlations between those created new columns. So such type of feature engineer approach, because we have to always remember that there is no added value for any newly created feature if it does not show any correlation with other columns. It would be like something not useful for our model to use. So that's why it's set over here, like you have those multiple options as of now, but definitely like whether from Alteryx or any enhancement that would be applied in the future, it could include something more like that have manual control. But in the meantime, those are like the common primitives that can be created or usually created by data scientists and machine learning pipeline. You can see here like you can see over here the correlation with this newly added column, like the estimated salary greater than age. It shows zero correlation with the age or the purchase. So it's not that useful to add it, but and still also over here, you can see like you can have a graph that shows you, let me select the estimated salary. Okay, sorry, this one, the purchased. So you can see here like the gradient for the count and stuff like this, but in this specific example, it does not have any added value because you can see there is no correlation in the newly imputated column. So we can uncheck this one and save the changes. Let me check this question. If you had similar data like number of years, active customers versus sales revenue, could you use the same model already trained by your age versus salary data? Okay, so basically, Jason, let me answer your question. So this model, and you're gonna see in a bit, whenever we're gonna import it in Alteryx Designer, it's specific to this model for this data set I'm using. But whenever you wanna use like a new data set, even if the data looks similar to this one, but I believe it's better to retrain the model again, because like the hidden information or correlation that is that would be showing, the model will interpret it in a different way, since it's not the case all the time that we're going to see like similar behavior. But from a technical perspective, but it would have like zero value or zero added value in terms of prediction. And you're going to see it in a bit whenever I'll jump to the Alteryx Designer part. You will see that whenever you gave the Cloud ML tool from Alteryx the same data set with the same column names, you will be able to use it on the same model. But it would be misleading to use the same names with different data set in terms of like including a different data set that was trained on it. Definitely unhidden, unseen examples are valid to use, but I cannot use like active customers for sales with another one for age and salary data, because both data sets would include different correlations, different learning process. It all depends on the initial data you're training, but like this is my answer for this. And for a repository of models and features to adapt for other users, actually in the meantime, since this tool is the all-in-one tool, you can see all the options from the data insight part. So far we have three main machine learning methods: the regression, the classification, and now you're going to see in the auto model part. So I'm going to jump to the auto model part. Over here, it automatically runs multiple models, and there is no need to set from your end any like model or repo for the trained one. Since everything is encapsulated in the cloud and applied over here, all you need to do is to set those parameters at as the machine learning classification problem or regression or time series you're using. And you will be able to use or export this model to Alteryx Designer. Okay, so now over here you can see it's running the auto model part. In the auto model part, multiple models run at the same time. You will get also like multiple evaluation metrics in order for you to see which model performs better than the other one according to the evaluation metric you're using. And we're gonna see it in a bit whenever this job finish from here. So this will like, in this step over here, you will see also one of the strength point of this approach. So everything is running on the cloud, everything instead of running it locally on your machine, in addition to running those multiple models without the need to any configuration for every model separately. So we're not here dealing with the configuration for the models. Everything is handled from the back end, from the cloud. And all we have to do whenever this will finish now in a bit, I believe it's taking a little bit more time because I set the holdout for 10%. It was 20%. So it should be almost done. Okay. So now you can see here on the screen, the suggested selected model is the random forest classifier over here. Our ranking metric is set to be the accuracy. If you remember, we set it from the feature engineering part before. We're more interested in getting a higher accuracy. Those are all other classifiers that were running in the background while we were waiting. And you can see like here is the baseline classifier. You can see that this model had performed 25% better than the baseline. You can see that the score was 0.9. There is the logistic regression, the cat boost, the light GBM classifier, and so on. So imagine like running those 8 models in Alteryx or in Python, Alteryx Designer, or even Python. Every single model needs like more time in configuring it and coding it. So it was just a matter of minutes over here. And if you go to the feature part, you can see what are the selected features for the model training part. And also you can change your ranking metrics. And whenever you change the ranking metric, the available model, like let's say we're gonna check for the F1 score. So you can see here, it's still the random forest comes in the first ranking. The score is less than the accuracy. It's 0.86 over here, whereas the accuracy was 0.9. I'm gonna keep the accuracy ranking metric and click on next. You can see over here also in the evaluation part. First of all, this is the pipeline flow chart. Like there are the features, the target feature that we got as a holdout, the transformation part. There was replacing, it passes through the replacing nullable types, transformer, imputer, which is in the future engineering part, in case we have created any new value. The cross-validation accuracy performance was showing 0.9. This score over here is for the 20% sample size that we've took from the original holdout. I believe we kept it as 20, not 10. I was telling you 10, but this was the default one. In the performance part, you can see other metrics also in the accuracy, like for this specific model, since we have selected the random forest classifier, you can see the accuracy score, the log loss, and other metrics for here is the area under curve, the F1 scored, and so on. You can see them all. You can also check for the, let me go to the There is another tab over here. Okay, this one. So in the insights part also, you'll be able to see how is every column or feature is important to our predictions. So you can see like here, the age has like 57% importance in our prediction compared to the estimated salary as 43%. So this is also part of like if we want to have it as an iterative process, you can see what is the most added value column. And definitely this is expected over here for the age, since it was showing the highest correlation with the purchase target value. And this is like the partial dependence part. Let me check if this one had loaded properly also. Okay. Okay. So also over here, you can see every variable by itself. You can see like as the age value increases, there is high probability to have a purchase. And the same also applied for the estimated salary, except for this gap over here, which is showing like a local minimum over here. It's not like the local minimum and the training, but it's not a straight curve. And also you can see another in this other tab, like some explanations about the predictions we're having. Like if we want to interpret the results, let's say we're asking the question of why does this model assign a high probability to have this purchase prediction. Sometimes we'll be able to interpret it from the variables itself. Like over here, it can show you the best prediction with the lowest error. Like this one, it's showing age of 32 and estimated salary of 18K. If I go back to the partial dependence, sorry, to the partial dependence one, so the age is 32 and it's an 18K. So like the 32 one over here, the value it's over here, we have more confidence in saying that this customer will not have a purchase. There is a very low probability to have a purchase. And his estimated salary also is 18K, which exists in this one over here, which is very close to the low level of a purchase. And this one is labeled as a true negative, which is predicted as false, and it is false. And here you can see, like, since we're not having an overfit or something like this, you can see the highest error margins with those misleading observations. Like here, you can see someone who had an estimated salary of 96K with age of 46, and it's a false positive, and it was predicted to have a purchase, but the actual one should be false. And let's see why this is happening. And let us remember the estimated salary is 96K. 96K is somewhere over here, which shows a high probability of a purchase, and the age was 84. Also an 84, it's a very high probability of a purchase, but in reality, it was not the case. So that's why it was labeled as a worst prediction over here. You can see multiple examples for those interpretation. And here you have the simulation part as running a what-if analysis, as if you're imputing new columns with those two variables. So you can just run it on a new value here. It's something similar to what we're going to see in a bit when exporting this column, when we export this model to the next step, to Alteryx Designer. So let me now go to the next step for the model evaluation. Okay, so first of all, before checking the designer integration, one of the features that I highly liked and appreciate in this tool is being able to export a PowerPoint slide from this tool to everything I've passed through right now. So whenever you want to have like a summary of what was happening on, or what are the metrics we're using for evaluation or anything, you can see over here, this PowerPoint is automatically generated from this tool. You can see the correlation metrics for the closeness and relationship between the features we were using, the chord diagram that we were showing at the beginning, the target variables and how they are distributed, the curve over here, area under curve analysis for the true positive and false positive stuff, the confusion matrix as a summary for how many predicted as negative and they are actual negative, and the ones that were predicted as positive and actual positive, and the error and the predictions with the error part, mispredicted ones. Also, you can see the feature importance, everything we've passed through over there. There's no need to go again and again whenever you're sharing the model, or you want to keep like records of what is being literally applied. So you can see the feature importance over here and the partial dependence that I was showing you for the age and the estimated salary over here. So this is automatically also generated by this tool. Sorry, I wasn't sure. Were you able to see the PowerPoint? Let me share it. Okay, let me share my screen again. Okay, so after exporting this visual over here, we can integrate this model into Alteryx Designer. All you have to do is to export this one from here. You can click on it. So first of all, this machine learning predict, this one, the Cloud AutoML, you need to download it from Alteryx Intelligent Suite. It's called the machine learning, the Cloud Machine Learning Kit. And whenever you download it, this one is generated directly from Alteryx AutoML. What you need to do is you need to sign in to verify. Let me sign in from here on my account. So I'm gonna connect this project over here to what was being applied and initially through the steps we've applied a minute ago. So it's already verified. I'm gonna select the selection, the project I was using. It's called the webinar. It was modified like minutes ago. And then I need to connect to this model over here. My input data, I'll connect data I was using, this one, the social ads network, but I need to do something before. I need to unselect the target variable. So what this block over here will expect, whenever we have a new data about social network ads or any type of data that we were using for the training part, we will use it as an input for this tool after we configure the connection to our Alteryx account. And also we need to remove the target variable, the target value, since we're expecting new observations. And then what we need to do is to click on run and wait a little bit. So we will get all the predictions with the accuracy of the prediction for every observation. So it will create 3 new columns: the predicted value, the precision or the probability of having a true, and the probability of having a false. Since we're in a classification, we're using a classification machine learning model. So here is the purchased column. So remember here, the input data did not include the purchase column. And over here, you can see the purchased column. This one is the predicted one from the model. No need to rerun anything on the model. This is just a connector to the AutoML on the cloud. And we have selected, you can have multiple models over here. All you need to do is to configure which one to select and just give it the input data from here. And you have the prediction probability, the false prediction probability, and the true prediction probability. So here you have 0.99 as false. So that's why it was predicted as false. And the same applies to the true part. Definitely those like 100% split if you sum them up. And this way, like a brief about Alteryx AutoML and all the steps involved in preparing this pipeline, into integrating it into Alteryx Designer, and having it connected to the AutoML from Alteryx Designer 2, and selecting the model and signing in, and so on. So is there any question, any step you want to go over it? I'm ready to get your questions. Was it that clear that you don't have any question till now? All right, guys. So basically, that's it for today. And also remember, if you have any question you want to send us an email, I believe you can see my email over here in the chat or from the webinar link you had before. So don't hesitate to send us any question about this tool, and we will be more than happy to help in that. And thank you all for attending, and see you next time.